40, 43, and 44, graphing those trig functions, one with degrees and one with radians. So kind of a quick idea, if we're in degrees, then our period being 2 pi over b, it's really going to be, is going to be 360 divided by b. And both of our problems here have b in it, so that's what we'll deal with. Okay, so again, our 1/2 here is our amplitude, which I think about how high or how loud. Instead of this theta, and theta could be x, it could be whatever, I'm going to think of this instead of as 1/4 times theta. Okay, now remember too, if it's just written cosine of 4 theta minus, I don't know, 90, in order for us to graph it correctly, we have to factor out that 4 and then take our 90 divided by 4, so that when we're dealing with our transformations, we're doing it correctly. So that would be a 22.5 instead of a 90 degree. Okay, so if you don't see parentheses and you see something connected with this, make sure that you factor it out. Okay, so here's our midline. Our amplitude is going to be 1/2. We'll just make them big. I think on your guys' graph, it's already on there, so you have to be careful as far as, I mean, that one's going to be really smooshed, but all right. All right, so our b is 1/4, so that means our period is 360 divided by 1/4, right? So that's really 360 times 4. Remember our fractions? All right, so 360 times 4 is 1,440 degrees. Okay, so again, that b means in a normal span of the normal period, 360 or 2 pi, how many cycles, how many graphs can you fit in there? In this case, we only get 1/4 of one graph in the normal period. So basically that means this one is super long and spread out. That's why your degrees are so big on their key. So if that's 1440, the middle of that is going to be our 720. Okay, middle of that's going to be our 360. So what would normally fit one full cycle in 360 is only going to be 1/4 of it. Yeah, and then what's in between that? 1440 and 720, 1080. Okay. So again, if you're trying to figure out your landmarks too, you can take your period and divide it by 4. And you get 360, duh, because you just multiplied it by 4, right? So that tells you what I call your landmarks and your steps to get there. All right, so we have our amplitude. We know it's cosine, so our cosine is going to start up, right? Because cosine at 0 is 1 on the unit circle. So it's going to go up, middle, down, middle, up, connect your dots, hopefully better than mine, and there you go. So again, what would have normally fit all the way right in here now is spread out because of this B. It changes things. Oh, look at the pretty colors. All right, so let's do blue. All right, so number 40, our amplitude is 3. So we're going to have to go from our midline, and notice there's no vertical shift, no phase shift, so our midline stays at 0. So 1, 2, 3, 1, 2, 3. Okay, so we took care of that. Now we have 4, for our B is 4. So that means we're going to take our 360 divided by B, and we get 90 degrees. So again, now that means that what would have normally been one cycle in 360, we now get 4. So this one is kind of smooshed together. And if we have, here's our 360. So here's our 180, our 90 and 270, which are our landmarks on the unit circle, right? Now this whole graph has to fit inside that 90. Okay, so we'll go purple. Going nuts with the colors. So there's 45, 22.5, and then 22.5 that way. So cosine starts up at 3, middle, down, middle, and up again. So again, this one is tall. Now that's a pretty graph. Oh my gosh. Good thing I don't get paid for my artwork like Mr. Lopresti does. So again, if you want more than one cycle through here, then you just chop this into fourths and do the same thing. Up, middle, down, middle, up. Okay? All right. So that was with degrees, where our period is 360 instead of 2 pi. And then they want radians. Look at that. All right. So same thing in radians. Our amplitude is 2. Our b is 3. So we have 2 pi divided by 3. So our period now, instead of being 2 pi, is 2 pi over 3. Okay, so what does that mean for our steps, for our landmarks? If I take 2 pi, divide by 3, and I divide it by 4, which is the same thing as multiplying by 1/4, each one of my steps is going to be 2 pi over 12, or pi over 6. Okay. So if I say, okay, here's, we'll just, I think on yours it shows you where the landmarks could be. So we know one period's going to go through 2 pi over 3. Okay, so it's going to start, I always go middle, chop that in middle, chop that in the middle, and in half there. So this is pi over 6. Okay, then I add a pi over 6, which is 2 pi over 6, which is pi over 3. Right, makes sense. If that's 2 pi over 3, half of that is 1 pi over 3, right? And then I add another 1/6 pi. So 1, 2, 3 pi over 6. Well, that's just pi over 2. Okay. Cosine starts up at 2, up, middle, down, middle, up. Bum, bum, bum. And booyah, there you go. Okay. So hopefully you guys notice that all of these things that we do are just techniques. So the technique stays the same, right? Even though the math gets uglier. But how we deal with sine or cosine is going to stay the same. All right, so this one, amplitude is 1. Right, no phase shift, no vertical shift. So these are easier actually than, I think, than the examples I did. But again, I'm going to write this one as 1/3 times theta. So again, we're going to get 1/3 of the graph in the same frame or space 2 pi that we would have. So this one's going to be really long, right? It's kind of stretched out. So 2 pi divided by 1/3 is the same thing as 2 pi, right? Flip and multiply. So our period of this function is 6 pi. Okay. Half of that is 3 pi. Half of that is, oh, there's Lucy. Gosh, she has to chime in every time. Lulu, she probably wants her cereal. Okay, so 3 pi, what's half of $3? $1.50, so 3 pi over 2, 1.5 pi. In between here, what is that one going to be? 4.5 pi. So what's 4.5? Come on, need the pencil back. 4.5, so that's 8, 9 pi over 2. You'd think I'd just pull that out of my noggin, but oh no. I can do calculus, but I can't add anymore. Okay. Cosine amplitude is 1. Say it with me now. Up, middle, down, middle, and up. And